again. So today we're going to learn lesson 5.4 about standard form. Let's start. When numbers are very small, like 0.00000362, are very large, like 358 million, calculations can be time-consuming, and it is easy to miss out some of the zeros. Standard form is used to express very small and very large numbers in a compact and efficient way. Numbers in standard form, numbers are written as a number multiplied by 10 raised to a given power. Standard form for large numbers. The key to standard form for large numbers is to understand what happens when you multiply by the powers of 10. Each time you multiply a number by 10, each digit within the number moves one place, ordered to the left. Notice that it looks like the decimal point has moved one place to the right. So as you can see here, the digit times 10, and the digits have moved one place, ordered to the left. If the power of 10 is 2, then the digits have moved 2 places. If the power of 10 is 3, then the digits have moved 3 places. And so on. You can see a pattern forming. Any large number can be expressed in standard form by writing it as a number between 1 and 10 multiplied by a suitable power of 10. To do this, write the appropriate number between 1 and 10 first, using the non-zero digits of the original number, and then count the number of places you need to move the first digit to the left. The number of places tells you by what power 10 should be multiplied. Write 320,000 in standard form. Start by finding the number between 1 and 10 that has the same digits in the same order as the original number. Here, the extra 4 zero digits can be excluded because they do not change the size of your new number. Now compare the position of the first digit in both numbers. 3 has to move 5 place orders to the left to get from the new number to the original number. The first digit 3 has moved 5 places, so you multiply by 10 to the power of 5. Calculating using standard form. Once you have converted large numbers into standard form, you can use the index laws to carry out calculations involving multiplication and division. Solve and give your answer in standard form. So you simplify by putting like terms together. Use the laws of indices where appropriate. Write the number in standard form. You may be asked to convert your answer to an ordinary number. To convert 6 times 10 to the power of 11 into an ordinary number, the 6 needs to move 11 places to the left, like this. So the answer 16 times 10 to the power of 10 is numerically correct. But it's not in standard form because 16 is not between 1 and 10. You can change it to standard form by thinking of 16 as 1.6 times 10. So here you simplify by putting like terms together. And now you use the laws of indices. When adding or subtracting numbers in standard form, it is often easiest to rewrite them both as ordinary numbers first, then convert the answer to standard form. Exercise 5.12. Write each of the following numbers in standard form. 380. 4,200,000, 45 billion and 6 million, 35 trillion and 4 billion. 20, 10, 10.3, and 5. Question 2. Write each of the following as an ordinary number. 2.4 times 10 to the power of 6. 3.1 times 10 to the power of 8. 1.05 times 10 to the power of 7. And 9.9 times 10 to the power of 3. 7.1 times 10 to the power of 1. Question 3. Simplify each of the following, leaving your answer in standard form. Open bracket, 2 times 10 to the power of 13, close bracket, times open bracket, 4 times 10 to the power of 17, close bracket. 1.4 times 10 to the power of 8, close bracket, times open bracket, 3 times 10 to the power of 4, close bracket. Open bracket, 1.5 times 10 to the power of 13, close bracket, squared. Open bracket, 12 times 10 to the power of 5, close bracket, times open bracket, 11 times 10 to the power of 2, close bracket. 0, open bracket, 0.2 times 10 to the power of 17, close bracket, times open bracket, 0.7 times 10 to the power of 16, close bracket. Open bracket, 9 times 10 to the power of 17, close bracket, divided by open bracket, 3 times 10 to the power of 16. Open bracket, 8 times 10 to the power of 17, close bracket, divide by open bracket, 4 times 10 to the power of 16, close bracket. Open bracket, 1.5 times 10 to the power of 8, close bracket, dividing by open bracket, 5 times 10 to the power of 4, close bracket. Open bracket, 2.4 times 10 to the power of 64, close bracket, divide by open bracket, 8 times 10 to the power of 21, close bracket. .44 times 10 to the power of 7, close bracket, open bracket, 1.2 times 10 to the power of 4, close bracket. Open bracket, 1.7 times 10 to the power of 8, close bracket. Open bracket, 3.4 times 10 to the power of 5, close bracket. Open bracket, 4.9 times 10 to the power of 5, close bracket, times open bracket, 3.6 times 10 to the power of 9, close bracket. Question 4. Simplify each of the following, leaving your answer in standard form. Open bracket, 3 times 10 to the power of 4, close bracket, plus open bracket, 4 times 10 to the power of 3, close bracket. Open bracket, 4 times 10 to the power of 6, close bracket, minus open bracket, 3 times 10 to the power of 5, close bracket. Open bracket, 2.7 times 10 to the power of 3, close bracket, plus open bracket, 5.6 times 10 to the power of 5, close bracket. Open bracket, 7.1 times 10 to the power of 9, close bracket, minus open bracket, 4.3 times 10 to the power of 7, close bracket. Open bracket, 5.8 times 10 to the power of 9, close bracket, minus open bracket, 2.7 times 10 to the power of 3, close bracket. Standard form for small numbers. You have seen that digits move place order to the left when multiplying by powers of 10. If you divide the power by powers of 10, move the digits in place order to the right and make the number smaller. Consider the following pattern. 2,300. 2,300 divided by 10 equals 230. 2,300 divided by 10 squared equals 2,300. Dividing by 100 equals 23. 2,300 divided by 10 to the power of 3 equals 2,300 divided by 1,000 equals 2.3, and so on. The digits move place order to the right. Notice that this looks like the decimal point is moving to the left. You saw in chapter 1 that if a direction is taken to be positive, the opposite direction is taken to be negative. Since moving place order to the left raises 10 to the power of a positive index, it follows that moving place order to the right raises 10 to the power of a negative index. Also, remember from chapter 2 that you can write negative powers to indicate that you divide. And you also saw above that with small numbers, you divide by 10 to express the number in standard form. Word example 19. Write each of the following in standard form. 0.004, 0.00000034. Open bracket 2 times 10 to the power of negative 3, close bracket, times open bracket 3 times 10 to the power of negative 7, close bracket. Start with a number between 1 and 10, in this case 4. Compare the position of the first digit. 4 need to move 3 place orders to the right to get from the new number to the original number. In work example 17, you saw that moving 5 places to the left meant multiplying by 10 to the power of 5. So it follows that moving 3 places to the right means multiply by 10 to the power of negative 3. Notice that also the first non-zero digit in 0.004 is in the third place after the decimal point, and that the power of 10 is negative 3. Alternatively, you know that you need to divide by 10 3 times, so you can change it to a fractional index and then a negative index. So notice that the first non-zero digit in 0.00000034 is in the 7th place after the next decimal point, and that the power of 10 is negative 7. In C, you simplify by gathering like terms together, and you use the laws of indices. Exercise 5.13. Question 1. Write each of the following numbers in standard form. 0.04, 0.004, 0.00005, 0.0000032, 0.00000000564. Question 2. Write each of the following as an ordinary number. 3.6 times 10 to the power of negative 4. 1.6 times 10 to the power of negative 8. 2.03 times 10 to the power of negative 7. 8.8 times 10 to the power of negative 3. 7.1 times 10 to the power of negative 1. Question 3. Simplify each of the following, leaving your answer in standard form. Question 4. Simplify each of the following, leaving your answer in standard form. Applying your skills. Find the number of seconds in a day, giving your answer in standard form. The speed of light is approximately 3.1 10 to the power of 8 meters per second. How far will light travel in 10 seconds, 20 seconds, 102 seconds? Data storage in computers is measured in gigabytes. 1 gigabyte is 2 to the power of 30 bytes. Write 2 to the our 30 in standard form. Correct to one significant figure. There are 1,024 gigabytes in a terabyte. How many bytes is this? Give your answer in standard form. Correct to one significant figure. So that's the end of this video. Thank you and goodbye.